just finished organic chemistry, this top reaction here should look very familiar to us. This is a primary alcohol, ethanol. It is being converted to ethanal, an aldehyde, through the process of oxidation. It's a term we used when we said that acidified dichromate caused a change in the structure. In this case, the change that occurred is that the initial reactant, the alcohol, loses a pair of H's, this one from the carbon, and that one from the hydrogen to form the double bond. The term we used in this case was oxidation. So one of the earliest definitions that they talk about for oxidation is through the loss of hydrogen. Other things that people have seen in the environment are conditions where, for example, iron metal sitting out in air forms iron oxide. In this case, it's called iron 3 oxide. And we know this commonly as rust. Now, when we look at the process, the question is, what happened to the iron? Well, iron is an element. Elements are made of atoms, and atoms are considered to be neutral. They have the same number of protons and electrons. So we can say that iron here has a 0 charge on it. There's one thing we'll find out that is typically considered true of any element. Oxygen is the same way. This is pure oxygen, elemental oxygen, and we say that in this case it also has a 0 charge. From experience in ionic compounds, we've learned that oxygen, when it forms an oxide, typically has a -2 charge on it. So each of the oxygens here ends up with a -2 charge. Now, because there are a number of oxygens, being 3 of them, the combination of the 3 oxygens times 2 gives us a -6 charge. Now we've learned that compounds have to be neutral. That means that the combined charge of the ions together has to have a +6 charge. That means the iron, individually, there were 2 of them, must have a +3 charge. So we can ask the question, what happens to the iron? Well, the iron goes from an iron 0 as its reactant to an iron +3. In order to become a positive charge, we know that what has to happen is electrons have to be changed, and that must mean that there's been a loss, in this case, of 3 electrons. That allows the positive charge to exist. So this is another way that we can talk about oxidation. So we have a loss of hydrogen in an organic molecule. We also have loss of electrons here, as we can see. So what occurs in this case? Here is copper. Copper, being an element, again has a 0 charge. Oxygen also a 0 charge. The oxide we've seen before has a -2 charge, which means in this case that the copper must have a +2 charge. So watching the copper go from copper 0 to copper +2, we find again that what's happening here is a loss of electrons. In this case, 2 electrons. So in the language, we're going to say here that in general, as the statement, that a loss of electrons or loss of hydrogen, these kind of reactions are called oxidation. This first definition here, this one, is our more current definition, and we'll find that we can actually prove that this is true here, but we'll stay with the archaic definition for a moment. When I look at these processes, here's copper oxide reacting with hydrogen gas to make copper metal and water. What happens here? Okay, so here's our copper with a -2 charge. The copper must have a +2 charge on it because the oxygen at the -2, this is 0. The elements are a zero charge. Since elements are zero charge, this copper must have a zero charge. From our learning about oxygen, we can hypothesize that this oxygen also is -2, and the combined charge on the H's is +2, meaning that each H has a +1 charge. So a couple things have happened, but let's focus on the copper. So what took place here for the copper? The copper went from a +2 charge to a 0 charge. To get rid of a positive charge, we must have a gain of electrons. We're going to call this process a reduction. Let's look at an example in the organic chemistry world. This is ethene. Remember how that looks? C, double bonds. Okay, so this is our place. And we know that with double bonds, there's a common reaction called an addition reaction. So let's bring in hydrogen gas, allow it to react, and form an alkane. And what happens here? In this case, what we're seeing is we're noticing that this is the addition of H. So we're going to find out what's in common in this case is that either a gain of electrons or adding an H are considered to be reduction. And this is the theme of what we're going to be talking about in this particular unit, is the idea of electrons being moved. Oxidation, reduction. Again, we're going to stay with the modern definition here. This is going to be our focal point. And so overall, we're going to be talking about this idea of what are known as redox reactions. Which involve either a gain or loss of electrons. What we'll learn is that they occur as a pair, and so one substance gains and the other loses.